Our next topic in this chapter is about rigid transformations. Now, rigid transformations are something you have already learned about before, but we probably didn't put this name with it. The technical definition of a rigid transformation is a geometrical term for the preimage and the image both having the same exact size and shape. So what I have down here in my typical format, sometimes I understand a picture a little bit easier than I understand a definition. At the bottom of my page, I have an example of a preimage, meaning before a transformation has taken place, and an image. When I look at the preimage is an isosceles triangle. And between the preimage and the image, it looks as though the shape may have been turned, or flipped, or slid to its position that it has now. Take a look at the image. Look at how it is labeled. The image is labeled by tick marks as well, and the letters have a little apostrophe, or it almost looks like a little 1 beside it. The way that we read this is A prime. A prime reflects the point A after it has been transformed. Take a minute, and if you need to rewind or pause, go ahead and do that to go through this step again. There are 3 types of rigid transformations, and again, these words probably don't look very different to you. You've seen them before. The first type of transformation that we're going to talk about in this video is translate. Translate, I always like to use a little device here, has SL as 2 of the middle letters because translate is a slide. We can slide to the left, to the right, diagonally, up, down. We can slide in all kinds of different movements. Reflect, their middle letters are F and L. Reflect is a flip. I can reflect things up, down. I can reflect it over an axis, which we'll talk about as well. And then the final rigid transformation is a rotation. Middle letter here is T. Rotate means to turn. For the next few days, this is what we're going to be focusing on, and then we'll take it and apply it to some of the things in real life. First things first, I included this in your notes because I just wanted you to take a look at what a translation looks like outside of a coordinate plane. The figures that are translated are transformed across a vector. These red lines represent a vector. The vector represents a direction and a degree in which something is moving. We will learn more about vectors when we talk about trigonometry. The second statement is very true, and I warn you that you may see something like this coming up on your benchmark. In order for something to be a true translation, the vectors of each point must be parallel. So that means that this trapezoid must be parallel to the trapezoid that's over here. And again, I labeled it how we have it labeled, and that's what we've got for that. And again, the vectors are the dashed lines. The first example that I have for you is plotting a triangle ABC. What we're going to do is we're going to take this and we're going to actually translate it. If you've remembered doing translations in the past, I would suggest that you just take your time right now, pause after each step, and see if you can follow the directions. So step 1 says that we need to plot triangle ABC at the places that are labeled here. Go ahead and pause and do that, and then come back in about 5 seconds. So triangle ABC has been placed, and we're going to translate it across this vector. Now, this textbook uses the phrase vector, but you probably will see more often an algebraic rule. This is the algebraic rule that the vector means. Just like an ordered pair, the first number represents x, the second number represents y. So what we're going to do is we're going to take this original shape and we're going to move it 4 to the right, and then we're going to move it 3 down. Go ahead and move your triangle to its proper location and come back and check that it works where mine is at. So I'm going to come back up here again and make sure we see where we're moving. So we're moving over just 1, 2, 3, 4. And then we're going to slide down 1, 2, 3. Step 4 is something that you don't really necessarily need to draw, but it's something you need to be aware of. In order for the triangles to have been properly translated, that means if I were to connect a line from A to A prime, B to B prime, and C to C prime, all of those segments would be parallel. Take a minute before we move on to the next question and write the points for A prime, B prime, and C prime. For our last example, we're going to take a look at another triangle. Take a minute, pause the video, and plot the first triangle. Our rule this time now is -3 and 0. See if you can come up with how that would be written as an algebraic rule, and I'll show you the answer in a couple seconds. Notice nothing changes to the y. That means this is not a diagonal slide, we're just shifting to the left, and that is it. So my shift to the left says I want to move 3 units to the left, and this is where we would end up. Take a minute on your own to find out what the new points are for A prime, B prime, C prime, and determine if the vectors are parallel. At this point, you have an assignment on Edmodo where you need to go through and do a couple things for practice. Please go ahead and do that now.